So hello again, Level 3 Cambridge Technical and Engineering Revision again, Unit 3 Principles of Mechanical Engineering, and we're looking at question 2. We're now looking at question 2 part B, which switches over from the inclined plane and starts to deal with kinematics. Okay, so looking at the question, the car now travels along a horizontal road. The highway code specifies that the vehicle travelling at 60 miles per hour, which is 26.8 meters per second, must be able to achieve a stopping distance of 55 meters when a braking force is applied. Assume that deceleration is uniform when a braking force is applied. Calculate the deceleration needed to achieve the stopping distance. So we're going from 26.8, 55 meters. At this point we should be at 0. Okay. Going to your formula book. 6.4 is kinematics, it's looking at acceleration, distance and time, and velocities. So we've got an initial velocity and a final velocity, and that definitely looks like what we've got here, an initial velocity and a final velocity. So we've got a v squared equals u squared plus 2as. So let me write that down. I think that's what I'm going to use. V squared equals u squared plus 2as, because s is the distance. It stands for displacement. Sometimes you use the term displacement. Excuse me. Right, so let's put some numbers into this and see what happens. So we want to get to 0. So put 0 squared is going to be equal to the starting velocity squared, 26.8. These squares are really important when you rearrange. Plus 2 times, that's the thing that we don't know, times the 55 that we do know. Right, I'm going to take a minute and just work through the rearrangement. So if we start off here, I've got v squared plus 2as, so this is positive, so we would end up with v squared minus u squared is equal to 2as, and these are multiplying the 2 and the s, so we would do divide, so we go to v squared minus u squared is going to be equal to a, let's put that over there like that, s. So we would end up with 0 squared minus 26.8 squared divided by 2 times the 55 is going to equal our acceleration. Bring in a calculator, so negative 26.8 squared equals, remember I like to do these in stages, so that would be minus 718.24 divided by, that's going to be 110, isn't it? So bring that back up, divide 110 equals, so the deceleration, negative acceleration is deceleration, 6.529 meters per second. So that is the answer that we'd be looking for deceleration. So just to finish this section then, so we've now got part B, part 2. the work done by the brakes of the car in this situation, the deceleration, this is from before, is 334,000, so 334,000 joules. Given that it takes 4.1 seconds to stop, determine the average braking power, average power of the car. We've got work done, and we've got time in seconds. So this is a dynamics question, so bring in the dynamics, and we've got average power is work done divided by time. So we've got a work done, which is 334 joules, and we're going to divide that by 4.1 seconds. So that's going to, it's a 1 mark question, so it's not surprising that it's not a massive amount to do. 334,000 joules divided by 4.1 equals 8146.4. Here's a nice, if you're not familiar with it already, if you look on your calculator, you'll find an engineering button, and you press engineering, because engineers like to work in multiples of 10, so times 10 to the, but we tend to work in 3, so times 10 to the 3, times 10 to the 6, times 10 to the 9. Press that, and we've got times 10 to the 3 here, so it's 81.46, and times 10 to the 3, I'll write out first, is, and this is a little long-winded to say, 81.46 times 10 to the 3. What we really mean is, more linguistically, is 81.46 kilowatts. Kilo being 1,000. And the W being capital because it's after the scientist watts. Which is the same with joules. And it's a point to note with regards to units. Making sure that the units that should be capital are capital, the ones that newtons, etc., and the ones named after scientists are capitals, and the others are lowercase. A slight difference to this is when we talk about when we're moving up the scale, mega and giga, they tend to be capital. So just be familiar with your units as you work through your revision. And I hope that's useful, and do well in the exam.